Okay, we're trying something new today. So this is follows on from our gingerbread attractor the other day. It turns out some of the stuff I told you last time wasn't exactly right. And because I've been fiddling with this, I've discovered something that I think I should share. So you recall that 5 and 2 were the values we started with when we did it by hand. I've implemented the formula from before in Excel. So this takes the row above the second row and does the 1 subtract the y value plus the absolute size of the x value. And this just inputs the y value. So we're going to do that a lot, down to 1,000-ish rows. Why not make it exactly 1,000 rows? And we are going to plot that as we did. Here I'm using a curve. So these coordinates are those coordinates joined with a smooth curve between them. Just going to make sure I've selected the correct data. Gone down to row 1,000, yeah, 1,001 rows. Now you will notice it doesn't look very gingerbready, and that's because it's only called gingerbread attractor because of something it looks like when we have a more continuous data set. So if I, instead of using integers to start with, oops-a-daisy, and use these formula up here to generate a random number continuously, you get the same iteration formula, but because these are completely random numbers now at the start and aren't linked to integers, the repetition is not as quick. The period is much, much higher. And you can see there's much more filled in. Still not very gingerbready. Now it turns out the actual error was we don't want to join these things up. We actually don't want the lines. And as you can see now, we've got kind of a pair of legs, kind of a pair of arms, and kind of a head. And if I change the random numbers, it will look more or less like a gingerbread man. So that doesn't look very gingerbready because those numbers repeat very rapidly. Whereas this repeats less often and looks more, or gradually more, like people, like a gingerbread man. So that's, I think, why this is called gingerbread attractor. I haven't actually checked still, doing my own research. And I haven't yet been able to work out how to predict whether it will be something simple like this that repeats very quickly, because I can't quite see any obvious link between these numbers that means that we could have predicted their very short repetition. If I look, it's only 6 points before they repeat again, compared with something else like this that repeats a long way before we get to 4.28 again, if we repeat at all, but therefore has a lot more points to fill in this gingerbready shape. Now, from this view, it's not very clear that it's kind of attracting around, but if we go back to putting those curved lines in again, you can kind of see the swirling around and sort of sinking into this vortex. Whilst it might try and escape, it doesn't escape. When it gets away, it gets sucked back again. So that's a little quick. That's an interesting one because that's clearly doing a lot of oscillations. It's not the same every time, but it doesn't look like it's going to be particularly. That's weird. I don't quite understand this yet. And such a simple idea, we're just adding some numbers together, just adding and subtracting numbers, and they produce these very peculiar, very interesting, not predictable patterns. So I hope you enjoy that, and I'll see you next week for some more GCSE type maths probably.